What are the functions of liquid, hybrid, and solid electrolytic capacitors? Electrolytic capacitors are a type of capacitor that uses an electrolyte as one of its electrodes to achieve a high capacitance per unit volume. There are three main types of electrolytic capacitors based on the electrolyte they use: liquid electrolytic capacitors, solid electrolytic capacitors, and hybrid electrolytic capacitors. Liquid electrolytic capacitors are a type of electrolytic capacitor that uses a liquid electrolyte to form the dielectric layer. Here are some key characteristics and considerations regarding liquid electrolytic capacitors. Construction. Liquid electrolytic capacitors typically consist of two aluminum foils separated by a layer of porous paper soaked in electrolyte. The assembly is rolled into a cylindrical shape and enclosed in an aluminum or plastic case. The liquid electrolyte serves as the dielectric material, allowing for a high capacitance value. Capacitance. Liquid electrolytic capacitors have relatively high capacitance values compared to other types of capacitors, making them suitable for applications where large capacitance values are required. Voltage rating. These capacitors are available in various voltage ratings, ranging from a few volts to several hundred volts, depending on the specific application requirements. Applications. Liquid electrolytic capacitors are commonly used in power supply circuits, audio amplifiers, and other electronic devices where high capacitance values and relatively low cost are important factors. Polarity. It's important to observe the polarity when using liquid electrolytic capacitors, as they are polarized components. Incorrect polarity connection can lead to capacitor failure or even explosion. Temperature and aging. The performance of liquid electrolytic capacitors can be affected by temperature variations and aging. High temperatures can cause the evaporation of the electrolyte and lead to a decrease in capacitance and an increase in equivalent series resistance (ESR) over time. ESR. Liquid electrolytic capacitors typically have higher equivalent series resistance (ESR) compared to other types of capacitors. ESR can affect the capacitor's performance, particularly in applications where low ESR is critical, such as in high-frequency circuits or voltage regulator modules. Lifetime and reliability. Liquid electrolytic capacitors have a finite lifespan, and their reliability can be affected by factors such as temperature, voltage stress, and operating conditions. Proper derating and selection of capacitors based on application requirements are essential to ensure reliability. Size and form factor. Liquid electrolytic capacitors are available in various sizes and form factors, including radial lead, axial lead, and surface mount configurations to accommodate different installation and space constraints. Overall, liquid electrolytic capacitors offer high capacitance values and are widely used in numerous electronic applications where these characteristics are crucial, despite their limitations related to temperature sensitivity, ESR, and lifespan. Power supply circuits. Liquid electrolytic capacitors are commonly used in power supply circuits to filter ripple voltage and stabilize the output voltage. They help smooth out fluctuations in voltage, ensuring a stable and reliable power supply for electronic devices. Audio amplifiers. Liquid electrolytic capacitors are often employed in audio amplifiers for coupling and decoupling purposes. They help block DC voltage while allowing AC signals to pass through, thereby improving audio signal quality and reducing distortion. Switching power converters. In switching power converters and voltage regulator circuits, liquid electrolytic capacitors are used to store energy and smooth out voltage fluctuations. They help improve the efficiency and performance of these circuits. Motor starters and controllers. Liquid electrolytic capacitors are used in motor starters and controllers to provide the necessary capacitance for motor starting and running operations. They help improve motor performance and efficiency. Lighting ballasts. Ballasts used in fluorescent lamps and other types of lighting fixtures often incorporate liquid electrolytic capacitors to regulate voltage and current, ensuring stable and efficient operation of the lighting system. Telecommunications equipment. Liquid electrolytic capacitors are used in telecommunications equipment such as routers, switches, and base stations for power supply filtering and voltage regulation. Industrial electronics. In industrial electronic equipment and control systems, liquid electrolytic capacitors are employed for various applications such as power conditioning, voltage regulation, and energy storage. Consumer electronics. Liquid electrolytic capacitors are found in a wide range of consumer electronics, including TVs, computers, gaming consoles, and home appliances. where they play a vital role in power supply filtering and voltage stabilization. Automotive electronics. Liquid electrolytic capacitors are used in automotive electronic systems for functions such as engine control, ignition systems, audio systems, and lighting control. Renewable energy systems. Liquid electrolytic capacitors are utilized in renewable energy systems, such as solar inverters and wind turbine converters, for energy storage and power conditioning purposes. Overall, liquid electrolytic capacitors are versatile components used in numerous electronic devices and systems across various industries due to their high capacitance values, relatively low cost, and effectiveness in filtering and stabilizing voltage. Solid electrolytic capacitors, also known as solid tantalum capacitors, are a type of electrolytic capacitor that utilizes a solid electrolyte instead of a liquid one. Here are some key characteristics and considerations regarding solid electrolytic capacitors. Construction. Solid electrolytic capacitors typically consist of a tantalum metal anode, which serves as one electrode, coated with a thin dielectric layer of tantalum pentoxide, Ta2O5. This dielectric layer acts as the electrolyte. A conductive polymer or manganese dioxide is then used as the cathode material. The entire assembly is encapsulated in a molded epoxy or polymer case. Capacitance. Solid electrolytic capacitors offer high capacitance values and a compact form factor compared to other types of capacitors. They are capable of providing capacitance values ranging from a few microfarads to several hundred microfarads. Voltage rating. Solid electrolytic capacitors are available in various voltage ratings, ranging from a few volts to several tens of volts, depending on the specific application requirements. Polarity. Similar to liquid electrolytic capacitors, solid electrolytic capacitors are polarized components, and observing polarity is crucial to prevent capacitor failure or damage. Stability and reliability. Solid electrolytic capacitors are known for their excellent stability and reliability compared to liquid electrolytic capacitors. They have longer operational lifetimes and are less susceptible to temperature variations, voltage stress, and aging effects. Low equivalent series resistance. ESR solid electrolytic capacitors typically have lower equivalent series resistance, ESR, compared to liquid electrolytic capacitors. This makes them suitable for applications where low ESR is critical, such as in high-frequency circuits or voltage regulator modules. Temperature stability. Solid electrolytic capacitors exhibit better temperature stability compared to liquid electrolytic capacitors. They can operate over a wide temperature range without significant changes in capacitance or performance. Applications. Solid electrolytic capacitors are widely used in various electronic applications, including telecommunications equipment, computer peripherals, automotive electronics, and industrial controls, where high reliability, long operational life, and compact size are essential. Size and form factor. Solid electrolytic capacitors are available in different sizes and form factors, including surface mount and through-hole configurations, to accommodate various installation requirements and space constraints. Overall, solid electrolytic capacitors offer several advantages over liquid electrolytic capacitors, including higher reliability, longer operational life, lower ESR, and better temperature stability, making them suitable for a wide range of demanding electronic applications. Solid electrolytic capacitors, also known as solid tantalum capacitors, have specific applications where their unique characteristics are advantageous. Here are some common applications of solid electrolytic capacitors. Aerospace and defense. Solid electrolytic capacitors are extensively used in aerospace and defense applications due to their high reliability, long operational life, and ability to withstand extreme temperatures and harsh environmental conditions. They are used in avionics, satellite systems, radar systems, missile guidance systems, and military communication equipment. Automotive electronics. Solid electrolytic capacitors find applications in automotive electronics, including engine control units, ECUs, airbag systems, anti-lock braking systems, ABS, infotainment systems, and safety systems. They provide reliable performance in demanding automotive environments with high temperatures and vibration levels. Industrial electronics. In industrial equipment and machinery, solid electrolytic capacitors are used for power supply filtering, voltage regulation, and energy storage. They are employed in motor drives, PLCs, programmable logic controllers, robotics, factory automation systems, and industrial control systems where reliability and stability are essential. Medical devices. Solid electrolytic capacitors are utilized in various medical devices and equipment such as patient monitors, medical imaging systems, MRI, CT scanners, defibrillators, pacemakers, and implantable medical devices. They meet stringent reliability and safety requirements in medical applications. Telecommunications equipment. Solid electrolytic capacitors are employed in telecommunications infrastructure equipment such as base stations, routers, switches, and optical networking devices. They provide high reliability and stability for power supply filtering, voltage regulation, and energy storage in telecommunications networks. Consumer electronics. Solid electrolytic capacitors are used in consumer electronics products such as smartphones, tablets, laptops, digital cameras, gaming consoles, and audio-video equipment. They contribute to power supply filtering, voltage regulation, and energy storage, ensuring reliable performance in various consumer electronic devices. Renewable energy systems. In renewable energy systems like solar inverters and wind turbine converters, solid electrolytic capacitors are used for power conditioning, voltage regulation, and energy storage. They provide long-term reliability and stability in renewable energy applications. Test and measurement equipment. Solid electrolytic capacitors find applications in test and measurement equipment such as oscilloscopes, signal generators, spectrum analyzers, and electronic meters. They contribute to stable and accurate measurement results in laboratory and industrial settings. Overall, solid electrolytic capacitors are used in a wide range of applications across industries where high reliability, long operational life, and stability are critical requirements. Their ability to withstand extreme conditions makes them suitable for demanding environments in aerospace, automotive, industrial, medical, and other sectors. Hybrid electrolytic capacitors are a type of electrolytic capacitor that combines features of both liquid electrolytic capacitors and solid electrolytic capacitors. These capacitors aim to provide a balance between high capacitance values and reliability. Here are some key characteristics and considerations regarding hybrid electrolytic capacitors. Construction. Hybrid electrolytic capacitors typically consist of a combination of liquid and solid electrolytes. The capacitor may contain a liquid electrolyte for its high capacitance properties while also incorporating a solid electrolyte or other materials for improved reliability and stability. Capacitance. Hybrid electrolytic capacitors offer relatively high capacitance values compared to other types of capacitors, making them suitable for applications where large capacitance values are required. Voltage rating. Similar to other types of electrolytic capacitors, hybrid electrolytic capacitors are available in various voltage ratings to suit different application requirements. Polarity. Hybrid electrolytic capacitors are polarized components, and observing polarity is essential for proper operation and to prevent capacitor failure. Reliability. Hybrid electrolytic capacitors aim to improve reliability compared to traditional liquid electrolytic capacitors by incorporating features such as solid electrolytes or other materials that enhance stability and reduce the risk of leakage or degradation over time. Temperature stability. Hybrid electrolytic capacitors may offer better temperature stability compared to traditional liquid electrolytic capacitors, thanks to the incorporation of materials that provide improved thermal performance. Applications. Hybrid electrolytic capacitors find applications in various electronic devices and systems where a balance between high capacitance values and reliability is essential. They are commonly used in power supply circuits, audio amplifiers, and other electronic equipment. Size and form factor. Hybrid electrolytic capacitors are available in different sizes and form factors, including surface mount and through-hole configurations, to accommodate various installation requirements and space constraints. Overall, hybrid electrolytic capacitors aim to combine the advantages of both liquid and solid electrolytic capacitors to provide improved performance, reliability, and stability in electronic applications where high capacitance values are needed. They offer a middle ground for applications that require a balance between capacitance and reliability. Hybrid electrolytic capacitors, which combine features of both liquid and solid electrolytic capacitors, find applications in various electronic devices and systems where a balance between high capacitance and reliability is essential. Here are some specific applications. Power supply filtering. Hybrid electrolytic capacitors are commonly used in power supply circuits of electronic devices, including computers, servers, and telecommunications equipment, where they help filter out noise and ripple voltage, ensuring stable and reliable power delivery. Audio equipment. In audio amplifiers, mixing consoles, and professional audio equipment, hybrid electrolytic capacitors are utilized for coupling, decoupling, and filtering purposes. They help improve the quality of audio signals by reducing noise and distortion. Automotive electronics. Hybrid electrolytic capacitors find applications in automotive electronics, including engine control units, ECUs, infotainment systems, and safety systems. They provide high capacitance for energy storage while ensuring reliability in harsh automotive environments. Industrial control systems. In industrial control systems, programmable logic controllers, PLCs, and automation equipment, hybrid electrolytic capacitors are used for power conditioning, voltage regulation, and energy storage. They offer high capacitance and long-term reliability in demanding industrial environments. Telecommunications infrastructure. Hybrid electrolytic capacitors are employed in telecommunications infrastructure equipment such as base stations, routers, and switches for power supply filtering, voltage regulation, and energy storage. They ensure reliable operation in telecommunications networks. Renewable energy systems. In renewable energy systems like solar inverters and wind turbine converters, hybrid electrolytic capacitors are used for energy storage, power conditioning, and voltage regulation. They provide high capacitance while withstanding harsh environmental conditions. Medical devices. Hybrid electrolytic capacitors are utilized in medical devices such as patient monitors, medical imaging equipment, and diagnostic devices. They offer high capacitance for energy storage while meeting stringent reliability and safety requirements in medical applications. Consumer electronics. Hybrid electrolytic capacitors are increasingly used in consumer electronics products such as smartphones, tablets, laptops, and home appliances. They provide high capacitance for energy storage while ensuring reliable performance in various consumer electronic devices. Overall, hybrid electrolytic capacitors are versatile components used in a wide range of electronic devices and systems where a balance between high capacitance and reliability is crucial for optimal performance and longevity.